Hi everybody, I'm going to go over how to do the graphing by hand. I just want to let you know I've already counted there's 40 spaces on the vertical or y-axis and there's 30 on the x-axis. The first thing that we're going to do is use a ruler, and I'm going to make my axes more distinct by using my ruler to outline them. The next thing I'm going to do is, it's a little hard to see. The next thing I'm going to do is look at the data, and I will just tell you that I've already done that. And since it's appropriate for this graph, we are going to start at 0. They don't have to start at 0, but it is appropriate for this. The variables that we're looking at are mass and volume, and because of a certain mathematical relationship, which you'll find here soon, I'm going to put mass on the y-axis. Notice that I'm turning it so that the word faces in, and then I'm putting the unit in parentheses. So I've got my label and my unit. On the x-axis, I'm going to put volume. Also notice that I'm leaving space between my words and the axes so I can put in some numbers. Again, on the x-axis, there's 30 spaces. There is no data that goes above 6. So I'm going to make my hatch marks every 5th line. And that's just to help my eyeball as I'm counting, right? Hatch marks are just there to help guide you. Notice there's a big space for each 1 milliliter. The mass in grams actually goes to 40 grams, so I have just enough room here with 40 lines. So I know my top is going to be 40. And again, if I put numbers every 5th line, it doesn't clutter up my data, my graph. So this is 5.00. Remember, mass is to the 100th place. This is 10.00, 15.00, 20.00, 25.00, 30.00, 35.00, and 40.00. So I have my axes labeled, I have my scale, I have my units. Now all that's left is to plot data points. You can plot data points by using different symbols. You can plot data points by using different colors. I strongly recommend that when you are starting to plot your data, that you do it in pencil, okay? So all of the data is listed for you, and I'm gonna start with aluminum, and then I'll make a second set of data for the iron. Pick a different color, pick a different symbol if you can't use different colors. Again, these are coordinate pairs, just like in math. So 2.0, 7.84. 2.0, comma 7.84 would be how you would see it in math. Okay, but we're just gonna plot all those points, and you get as good as you can get, okay? It doesn't have to be perfect. 8.82, but try and make the points obvious. 3.91. Okay, and eventually you'll have a fair amount of data points that you are able to do a line of best fit. Okay, I'm not going to graph all the points, but I do want to explain a line of best fit. So this line should go through 0, 0, because if something has 0 mass, it doesn't exist and it won't have any volume, okay? If 0 mass means 0 volume. That is for sure, all right? So when we're doing a line of best fit, there's actual mathematic equations you can use. I'm just eyeballing it to the best of my ability, and I'm just laying down a quick line here. It's probably not in the right place, okay? That would be my line of best fit. Notice none of my data points except the 0, 0 fall on the line. That's okay. I've got about equal spacing and equal numbers of points above and below. The next thing that you need to do is to find the slope. Little trick that I learned a long time ago that helps find the slope. Find a place, a corner that your line goes through. That way you can read it exactly. Remember, all of these are measurements. They're all subject to some error, but if you scan your line of best fit, that one's pretty good. That one's a little far off. This is really good. So I'm gonna use this corner, even though there's no data there, and I'm gonna draw a dashed line. I would like you to do the same. You won't be able to do this on the graph that is with the Google Sheets, but hang with me. Okay. And I want you to write this on your graph. If you're doing this by hand, I want to see this on your graph. Okay, so a couple things. Write the formula for slope. Slope equals change in y over change in x. Okay, you cannot count boxes because this is a different scale than this one. If I look at this, 4 to 5 milliliters, 0.2, 0.4, 0.6, 0.8, 5.0. So this is my x. My ending x is 4.4. My starting x was 0. Change in y. This time it's 1 at a time, so this is 14. Okay, I'm just gonna write these on here even though you don't need to write them on there. Okay, so the change in x, excuse me, the change in y is 14.0 minus 0. Obviously, we know it's 0, 0 because again, like I said, it has to be that way, okay? So if you think about it, what's on the y-axis? That's mass. What's on the x-axis? That's volume. Hopefully some of you are realizing that that means the slope of this line is the density. So now all we have to do is take our calculator, 14.00 divided by 4.4, and we get 3.18. Not bad. Not great, but not bad. And actually we should round that to 3.2. And again, this is grams and this is milliliters. So we've got 3.2, running out of space here, sorry, grams per milliliter. That's our slope for the aluminum line. And again, I didn't plot all the data, so yours might come out to be different. You might expect that, and excuse me, I'm gonna go back to the line real quick. You can go over this now with another color if you like. That would be fine. Okay, the next thing you're gonna do is plot the iron data, and you're going to hopefully see a very different pattern to the data. And that data, this one's really wonky. This guy's a bad data point, but anyway, you still have to include it. The data goes right on your graph, and hopefully you'll see that all the data points, here's the biggest one, 5.6 at 40, we just made it. Okay, all right, so I'm gonna stop there because I don't want to take too long, but again, it should go through 0, 0, okay? This data point is skewing my data a lot. I'm gonna go this way and eyeball it, and obviously I only have 4 points, you're gonna have more. So again, it may not turn out even close. I'm gonna do something like that, through 0, 0. Okay, same process, only up here you're gonna do the slope for the iron, and you're gonna find it, ooh, that's beauty. You're gonna find a place where the line goes through a corner. You're gonna read down to the x-axis for this as well. This is after all your data's on here. I'm just making a dashed line so it's easier. You can also use a highlighter and do that sometimes. Okay, so this is 24.00 and this is 3.2. So the slope again is change in y over change in x. That's mass divided by volume. In this case, the slope for this line, Fe is the chemical symbol for iron. The slope this time is 24.00 minus 0 over 3.2 minus 0. Run that through our calculator, and this one actually comes out pretty good as well. So it comes out to be 7.5, and again, mass is in grams, volumes in milliliters, grams per milliliter. Okay, so the final thing that you have to have, well, there's 2 more things. You need to have a title, and we talked about what goes first in a title. That was a terrible printing job, sorry about that. And then the other thing you need to have is a key or a legend, and it should go in a space where you do not have data. If you use the same color pen to draw your graphs, you should use a different symbol. If you use a different color pen to draw your graphs, then you can just use the symbol for each of the elements, but you have to tell the reader what they're looking at with these lines. All right, I hope that helps. Hope that wasn't too painful, and good luck.